Division. What's the deal?
What do you do if you want to share something, such as a six-pack of Mr. Pibb, equally with one of your friends? You can always just do the old one for you, one for me, one for you, one for me, one for you, and one for me to determine we each get 3 Mr. Pibbs. But is there a better way? There is a better way, and it's a mathematical strategy known as division, and this is the symbol we use to indicate division. Division is the process of calculating the number of times one number is contained within another number. From our earlier example, we could write the equation 6 divided by 2 equals 3. We want to determine how many 2's are contained in 6. In this equation, we call the 6 the dividend, the 2 is called the divisor, and the 3 is called the quotient. In other words, the dividend is divided by the divisor to get the quotient. But what if we had 120 Mr. Pibbs to share with 5 people? That's too hard, right? The answer is a resounding no. There is a strategy known as long division, and this is the symbol we use to perform long division. We put the dividend under the horizontal line on the right side of the vertical line. The divisor is placed to the left of the vertical line, and the quotient is written above the horizontal line. But how does that help us with the problem? First, we look at the hundreds place of the dividend, so in this case, 1, representing 100. We need to determine how many 5's, the divisor, are contained in 1. The answer is no 5's can be contained in 1, so we must also look at the tens place of the dividend. How many 5's are contained in 12? We know 5 times 1 is 5, and 5 times 2 is 10, and 5 times 3 is 15. So 2 5's are contained in 12, but 3 5's can't be contained in 12. We write the 2 5's that can be contained in 12 above the line and now must perform some multiplication and subtraction to determine what comes next. Since more than 2 5's can be contained in 12, we need to account for the leftovers. To do this, we multiply 2 times 5 to get 10 and write this number below the hundreds and tens places of the dividend. Next, we subtract 10 from 12 to get 2. We still need to account for the ones place of the dividend, so we must bring this number down and incorporate it in our previously performed subtraction. Now, we need to determine how many 5's are contained in 20. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and 5 times 4 is 20. We again must perform multiplication and subtraction to complete the problem. 4 times 5 is 20. This number is written below the tens and ones place of the dividend. Now we subtract. 20 minus 20 is 0. Our quotient is 24, and there are no extra Mr. Pibbs. This means if we wanted to share 120 Mr. Pibbs with 5 people, each person would get 24 Mr. Pibbs. Woohoo! That's a lot of Mr. Pibbs. But after all this math, I need a cold one. What do you say we go grab some Mr. Pibbs, you division-doing daddy-o?